Now, today we'd like to do change of subject. Now, change of subject, what does it basically imply? We have v to be equal to u plus at. Now, in this relation, we say that v is the subject of this relation. In the same way, we can decide to make u the subject. So if we want to make u the subject, so in this case, v is the subject. If we want to make u the subject, it means that let the u stand on its own. And in this case, it can be on the left-hand side or on the right-hand side. Now, in mathematics, most often, we let it be on the left-hand side. So in this case, if we want to make u the subject, we have v to be equal to the u plus 80. So if we want to make u the subject, this has to come in. So you have v minus 80 equal to u. Therefore, our u is v minus 80. In this case, we have made u the subject. We have a whole lot of cases that we are supposed to consider. We have about 4 different cases. Now, let's consider the case 1, whereby there's no fraction in the relation. Now, let's consider case 1, whereby it is non-fractional form. So here we consider that everything, there's no fraction in it. Now the first one is saying that we have x plus c equal to 4. We want to make x the subject, we want to make x stand on its own. So the c has to move to the right hand side. So we have x equal to 4 minus c. This is positive, crossing, becoming negative. Now the second one, we have w equal to 3t plus 11. We want to make t the subject, we want to make the t stand on its own. So what can we do? The positive 11 has to move to this side. We have w minus 11 equal to 3t. We want to make t the subject, so we divide by 3. So we have w minus 11 over 3 equal to 3t all over 3. This will cancel the 3, so we have t equal to w minus 11 all over 3. Now let's see the third question. We have 5p plus 7 equal to m. We want to make p the subject, so the 7 has to move to the right hand side. So we have 5p equal to m minus 7. We want to make p the subject, we divide both sides by 5, so clearly our p is m minus 7 all over 5. Now, let's see the fourth question. We have f equal to wp minus 16, and we want to make p the subject. So now let's take the negative 16 to the left hand side. So we have f plus 16 equal to wp. Negative crossing, becoming positive. We want to find p, so we divide through by w. So f plus 16 all over w, we have wp all over w. This is cancelling out that. So we have f plus 16 over w equal to p. Therefore, our p is equal to f plus 16 all over w. Now let's see the fifth question. We have v square equal to u square plus 2as. And we want to make s the subject. So this has to move here. So we have v square minus u square equal to 2as. We want to make x the subject. What is multiplying the s? That is 2a. So we have v square minus u square all over 2a equal to 2as all over 2a. This 2 is cancelling out that. Therefore, our s is equal to v square minus u square all over 2a. Now let's consider example 2. It says that make the variable shown in brackets the subject of the following. The first one, we are being told to make x the subject. So we have, that is 1, e to be equal to m, x minus c. And we are being told to make x the subject. So we have e to be equal to, we have mx minus mc. We have to use the distributive property to expand. We want to make x the subject. It suffices us to take the negative mc to the left-hand side. So it will be plus e plus mc equal to mx. We want to find x. We want to make x the subject. So we divide through by what is multiplying the x, which is m. So you have e plus mc all over m equal to mx all over m. This is cancelling out that. So you have our x to be equal to e plus mc all over m. Now let's see question number 2. We have AP equal to px plus c. In this case, we want to make p the subject. What can we say? There's p here, there's p here. So what are we supposed to do? Group like terms, and then because there's two p's in it, we have to, and p being a common factor, we have to factorize the p out. So you have AP minus px equal to c. There's p here, there's p. We factorize the p out. So p a minus x equal to c. We want to find, we want to make p the subject. So we divide by what is multiplying it, which is a minus x. So p a minus x all over a minus x equal to c all over a minus x. Clearly this and that is cancelling out. So we have our p to be equal to c all over a minus x. Now let's see the third one. The third one says that we have a equal to 2 pi r plus 2 pi r h. And we are being told to make h the subject. What are we supposed to do? Because we want to make h the subject, it is better we take the 2 pi r to the left hand side. So you have a minus 2 pi r equal to 2 pi r h. We want to make h the subject, divide by what is multiplying it, which is 2 pi r. So you have a minus 2 pi r all over 2 pi r equal to 2 pi r h all over 2 pi r. Now this is cancelling out that. So what do you have? You have our h to be a minus 2 pi r all over 2 pi r. What is the fourth question saying? We have a x plus 3 equal to by minus x. We want to make x the subject. There's x here, there's also x over there. What are we supposed to do on the left hand side? Use the distributive property to expand. So we have ax plus 3a equal to by minus x. From here, what do? We group like terms. So ax, negative ax, this has to come to the right, the left hand side. So we have ax plus x equal to by minus 3a. Now there's x here, there's x also over there. What do? X a common factor. We can factorize the x out. So you have x a plus 1 equal to by minus 3a. X times a, that is ax. X times 1, that is x. We want to find x, we want to make x the subject. Divide by what is multiplying the x, which is a plus 1. So we have x a plus 1 all over a plus 1 equal to by minus 3a all over a plus 1. So a plus 1 is cancelling out a plus 1. We are x to be equal to by minus 3a all over a plus 1. Now let's see the fifth question. We have r s minus x equal to 2x plus r. What do we want to do? We want to make x the subject. So what do we have to do? Use the distributive property to expand. So here we have rs minus rx equal to 2x plus r. From here, what do? We group like terms and we make x. So this is supposed to cross to this side and this is supposed to go there. So you have rs minus r equal to 2x plus rx. We want to make x the subject. X is common factor. So we factorize x out. We have 2 plus r. And this is rs minus r. We want to make x the subject. We divide by what is multiplying, which is 2 plus r. So rs minus r all over 2 plus r equal to x. We have 2 plus r all over 2 plus r. 2 plus r is cancelling out 2 plus r. So we have our x to be equal to rs minus r all over 2 plus r. Now let's see the second case, that is fractional form. And then in this case, we have two forms. That is, if it is of the form a over b equal to c over d. If you have something like this, what do? We cross multiply. So we say that AD is equal to B, C. Let's consider some example for better understanding. So the first one, we want to make P the subject. What do? We cross multiply. Now there's a 3 will come here, then the P minus Q go there. So we have 3P plus Q equal to 2P minus Q. Now what do? From here we expand. So we have 3P plus 3Q, 2P minus 2Q, 2 times Q, that is minus 2Q. We want to make P the subject, so from here we group like terms. So we have 3P minus 2P equal to minus 2Q minus 3Q. Now what is 3P minus 2P? That is P. Negative 2Q minus 3Q, that is negative 5Q. So clearly made P the subject. Now let's see question number 2. It is saying we have M all over M plus Y plus 2 equal to R all over Y plus R minus 1. We want to make Y the subject. What can we do from here? Cross multiply. So you have M, Y plus R minus 1 equal to R. M plus Y plus 2. Expand. So you have MY plus MR minus M expanding equal to RM plus RY plus 2R. Multiplying 2 with the R. We want to make Y the subject. Now there's Y here, there's Y also over there. Let's group the terms. So you have MY minus RY equal to RM plus 2R minus MR plus M. This negative crossing becoming positive. This is positive crossing becoming negative. Clearly this and that is cancelling out because RM is the same as negative MR. Y commutative, multiplication are what? Commutative. Now, so here there's Y here. So we have MY minus RY. What do you have? 2R plus M. There's Y common, so we can factorize Y out. You have M minus R equal to 2R plus M. We want to make Y the subject. What is multiplying the Y? M minus R, we divide both sides. Therefore, Y will be equal to 2R plus M all over M minus R. Now with this, we want to make Y the subject. Z equal to 3Y plus 2 all over Y minus 1. Now this Z is the same as over 1. Now from here, what can we do? We cross multiply. So we have Z, Y minus 1 equal to 3Y plus 2. We expand this. We have ZY minus Z equal to 3Y plus 2. We want to make Y the subject. There's Y here, there's Y here. We group like terms. So we have ZY minus 3Y equal to 2 plus Z. There's Y, there's Y, there's. We can factorize Y out. We want to make Y the subject. So we divide by what is multiplying over, which is Z minus 3. Clearly, this is cancelling out that. So we have Y to be equal to 2 plus Z all over Z minus 3. Now, this one, we are being told to make, that is U, the subject. Now, this X is over 1. So what can we do? We can cross multiply. So you have X, 3U plus 2 equal to 2U minus 3. We've cross multiply. So you have 3XU plus 2X equal to 2U minus 3. This has to come to the left-hand side because this is the same as, there's U there, there's U also over there. So you have 3XU minus 2U equal to negative 3 minus 2X. We can factorize U out. What do you have? 3X minus 2 equal to negative 3 minus 2X. From here, we can make U the subject by dividing through by what is multiplying, which is 3X minus 2. So U 3X minus 2 all over 3X minus 2 equal to negative 3 minus 2X all over 3X minus 2. Now this is dividing that. So we have u to be equal to negative 3 minus 2x all over 3x minus 2. Now in this case, we want to make m the subject. Now this is a past question. The h can be considered as h over 1. We can cross multiply. So you have h d, we have m plus p equal to mt. We cross multiplied. Now when we cross multiply, you can see that here hd times m, so you have hdm plus hdp. hd times m, hd times p of this equal to mt. You want to make m the subject. So let's take this. We can decide to bring this one to this side or take this to that side. Now let's take it to this side. So you have hdm minus mt. This can move here equal to negative hdp. We can factorize m out. That's what we want to make the subject equal to negative hdp. Therefore our m, we have to divide by what is multiplying the m, which is hd minus t. So you have minus hdp all over hd minus t. And this can be put as, this negative can come down, so you can have hdp all over t minus hd. While the negative multiplying by the, that will give us negative hd, and the negative and negative, that was what? Positive. Now let's consider question number 6. And this, what can we do? We can cross multiply. This is a past question. Cross multiply. So we have m plus y, n minus y. Now what is m times n? M squared. M times y, we have my. Now n times n, that is n squared. N times y, we have ny. We want to make y the subject. What can we do from here? Group like terms so that the y will be on one side. So it's better for us to bring this negative ny to the left hand side. So by doing so, we have ny plus my. Now the m square has to move to the other, so we have n square minus m square. What can we see here? y are common, so we have y n plus m equal to n square minus m square. Now we want to find y, we want to make y the subject. What can we even see here? This difference of two squares, so we can factorize this. We have n minus m, n plus m, y, n plus m. So we can divide through by n plus m. So y, n plus m all over n plus m equal to n minus m, n plus m all over n plus m. Now this is cancelling out that. This cancelling out this. So y to be equal to n minus m. Okay, the next one is a fractional form, still under the case 2. Now in this case, we normally multiply through with the LCM. And this, the LCM is the multiplication of the denominators. So the LCM, in this case, is BDF. So this implies that BDF times A over B, BDF times C over D, plus BDF times E over F. What can we see? The B over here is cancelling out the B over there. D here is cancelling out the D here. The F here is cancelling out the F over here. So what do you see? ADF, you can, the first one ADF, BFC plus BDE. And here, whatever you want to make the subject, you can make it from this case. Now, let's see this example. Now, in this case, it says that make the variable shown in bracket the subject of the following in each case. The first one, we have 1 over y equal to 1 over c plus 1 over x. What is the LCM? The LCM is y, c, x. So, in this case, we have the first one, 1 over y equal to 1 over c plus 1 over x. We want to make y the subject. We multiply through the LCM, which is y, cx. So you have y, cx times 1 over y. Y, cx times 1 over c. ycx times 1 over x. This y will multiply, will cancel this y. This will cancel this c. This x will cancel that x. So you have cx equal to yx plus yc. We want to make y the subject, so we factorize y there. So y, we have x plus c, we have cx. We want to make y the subject, we divide through by what is multiplying the y. So you have cx all over x plus c, y x plus c all over x plus c. Now x plus c will cancel x plus c. So y to be cx all over x plus c. Please note, this c cannot cancel the c down because c is not a factor of the denominator. Then x2 cannot cancel the x down because the x is not a factor of the denominator. Now we want to make the subject. So what do? We multiply through the LCM, which is m and p. So we have m and p times 1 over m plus m and p times 1 over n, m and p times 1 over p. This n is cancelling out n, m is cancelling out m, p is cancelling out this p. So we have np plus mp equal to mn. We want to make m the subject. So let's take this mp to this side. We are grouping like terms. So we have np equal to mn minus mp. Now we can factorize m out from the left hand side, from the right hand side, equal to np. We want to make the subject. So what do? We divide by the n minus p. So we have np all over n minus p equal to m. Therefore our m is np all over n minus p. Now in this case we want to make u the subject. 1 over u minus 1 over v equal to 1 over f. What's the LCM? Multiplication of the denominators, which is u v f. So you have u v f times 1 over u minus u v f times 1 over v. U v f times 1 over f. This u is cancelling out that u. The v is cancelling out that v. The f is cancelling out that f. So you have vf minus uf equal to u v. What do we want to do? We want to make u the subject. There's u here, there's u over there. So we group like terms. So you have vf equal to uv plus uf. Now over here, what can we do? We can factorize u out. That's what we want to make the subject. So you have u v plus f v f. From here, we can make u the subject by dividing through by the v plus f. So we have v f all over v plus f equal to u v plus f all over v plus f. This v plus f is cancelling out that v plus f. So we have our u to be vf all over v plus f. Now in this case, question number 4, 1 over m equal to t minus 1 over n. We are being told to make n the subject. What's the LCM? Multiplication of the denominators. We know t is over 1, so it's going to be mn. So multiply each term by mn. What can we see? This m is cancelling out that m, the n is cancelling out that n. So you have n to be equal to m nt minus m. We want to make n the subject. There's n here, there's n here. Now let me bring this m to this side and this n to that side. Negative crossing positive. M nt minus n. From here, what can we do? We can factorize n out. So m, we have n mt minus 1. This time this, we give out this time this, we give out that. We want to make n the subjects. We divide by what is multiplying the n, which is mt minus 1. Clearly this and that is cancelling out. So you have n to be equal to m all over mt minus 1. Now this NOVDEC 2019 question number 10, we are being told to make x the subject, x minus 1 over n plus y over n equal to 2. Now in this case, what are we supposed to do? Multiply through with the LCM. What is the LCM? mn. So the first term, mn, multiplied by the first term, mn, multiplied by the second term, 2mn. What can we see? This m is cancelling out that m, n is cancelling out that n. So what do you have? N x minus 1 plus my equal to 2mn. From here, what can we do? We can expand. So you have nx minus n plus my equal to 2mn. We want to make x the subject. There's x here. What do? Group like terms. All this has to move to the right hand side. We have nx equal to 2mn plus n minus my. Positive crossing becoming negative. We want to make x the subject, so we divide by what is multiplying the x, which is n. So clearly this n is cancelling that n, so you have our x to 2mn plus n minus my all over n. Be very careful, n is not a factor of the numerator, so the n cannot cancel out. Be very, very careful. So your answer can be in this form. Now let's consider this example. It is saying that x minus 1 over a plus y over b equal to 1. We should make x the subject. What's the LCM? The LCM is ab. So here the first place we have ab, first term all over a plus ab all over y over b. Then ab times 1. Now clearly what can we see? The a and a will cancel out, the b and b will cancel out. So you have this is cancelling out that, this b is cancelling out that. So you have b x minus 1 plus y equal to ab. We want to make x the subject. So what do? We expand using the distributive property. Bx minus b plus y equal to ab. We group like terms. So bx equal to ab plus b minus y. This has to move to the right hand side. We want to make x the side, so we divide by b. So you have x to be equal to ab plus b minus y all over b. Now we have this part we want to find. We want to make d the subject. There's d over here, so you have to do the bracket BODMAS first. Now, but what can we see? The LCM is 2. Now the s can be considered as over 1, so we can cross multiply. So we have 2s equal to n, and then we have 2a plus n minus 1d. Now this n is multiplying everything here, so we have to expand. So we have 2s equal to 2an plus n minus 1d. We want to make d the subject. What do? This 2a has to move to the left hand side. So we have 2s minus 2an equal to n minus 1d. We want to make d the subject. So what do? We divide by what is multiplying the d, which is n minus 1. So you have 2s minus 2an all over n minus 1 equal to n minus 1d all over n minus 1. Now this is cancelling out that. So you have our d to be equal to 2s minus 2an all over n minus 1. Now in this case, we want to make m the subject. We have m over v minus t over b equal to m minus t all over r. We want to make m the subject. What do? We multiply through the LCM, which is mbr. That is VBR, LCM. What can we see? This vein is cancelling another vein. This B is cancelling another B. This r is cancelling out that r. So what do you have? BRM minus VRT equal to VBM minus T. We want to make M the subject. There's M here, there's also M here. So what are we supposed to do? We are supposed to use the distributive property to expand this. So we have BRM minus VRT equal to VBM minus VBT. We want to make M the subject, so we group like them. This has to come to this side. We have BRM minus VBM equal to VRT minus VBT. Now there's M here, there's M here. What do? We factorize M out. So we have M BR minus VB equal to VRT minus VBT. What can we do? We can divide through by what is multiplying the M. So we have M BR minus VB all over BR minus VB equal to VRT minus VBT all over BR minus VB. Clearly this is cancelling out that, and we have our M to be VRT minus VBT all over BR minus VB. Now this case we want to make X the subject. You have d into bracket X minus 7 equal to 3 plus X minus B all over 5. We want to make X the subject. Now what is the LCM? The LCM is just 5. So multiply each term by the LCM, which is 5. So we have 5dx minus 7. 5 times 3. 5 times we have X minus B all over 5. This 5 is cancelling out that. So you have 5dx minus 7, or you have 15 plus X minus B. We want to make X the subject. There's X here, there's also X here. We have to use the distributive property to expand this. So we have 5dx minus 35d. 5d times 7, 35d equal to 15 plus X minus B. We want to make X the subject. There's X here, there's also X here. We have to group like them. 5dx minus X equal to 15 plus 35d minus B. Now, what can we see? X is common, so we can factorize X out. And we have 5d minus 1 equal to 15 plus 35d minus B. We want to make X the subject, so we divide by what is multiplied, which is 5d minus 1. So we have our X to be equal to 15 plus 35d minus D all over 5d minus 1. We want to make T the subject, and this is a past question. It says that U equal to 1 minus 3V all over VT minus W. What's the LCM? The LCM is just VT minus W. So you have to multiply each term by that. So you have U VT minus W. 1 VT minus W minus, that is VT minus W, and then we have 3V all over VT minus W. What can we see? This and that is cancelling. Now expanding this, we have U VT minus UW equal to VT minus W minus 3V. We want to make T the subject. There's T here, there's T here. So we have to group like terms. So we have U VT minus VT equal to UW minus W minus 3V. Negative crossing becoming positive. We want to make T the subject. So we factorize T because T is a common factor. T UV minus V equal to UW minus W minus 3V. So we want to make T the subject. So we divide by UV minus V all over UV minus V. UW minus W minus 3V all over UV minus V. This is cancelling out that. So we have our T to be UW minus W minus 3V all over UV minus V. Now let's consider this example. We are being given that is 2x minus y over z plus 2y over x, where x is 2, y is negative 3, and z is 4. Now this is a typical example of substitution. So with this, we have 2x minus y over z plus 2y over x. We are supposed to substitute the values. X is giving us 2, so we have 2 times x, we have 2 minus y. Our y is negative 3 all over z. What is the z? Z is 4 plus z, that is 4, plus 2, our y is negative 3 all over x. What is the x? X is 2. Now 2 times 2, that is 4. Negative and negative positive, so plus 3 all over 4. Plus, let's see, this is giving us 4 minus 6 all over 2. 2 times negative 3, that's negative 6. Now this will give us 7 over 4 minus 2 over 2. That is 4 minus 6 is giving us negative 2. Now from here we can find the LCM. What is the LCM? LCM is 4. 4 will go into 4, that is 1 times 7. We have 7. 2 will go into 4, that is 2 times. 2 times 2, that is 4. 7 minus 4 is 3. So our final answer is 3 over 4. Now let's see this example. This is an O-level past question. Now we are being given P to be equal to negative 2, Q is 3. That we are being told to evaluate P minus 2Q over P plus Q. Minus Q minus P all over Q plus P. Now, P is giving us negative 2 and Q is giving us 3. So you have to substitute. P, that is negative 2. Our Q is 3. P is negative 2 plus 2Q is 3. Minus Q, we have 3. Minus P, that's negative 2. All over Q plus P. 3 minus 2. Now, negative 2 times 3, that's negative 6. We have negative 2 minus 6 all over negative 2 plus is 2 times 3, that's giving us 6. We have negative here. Now this will be 3 plus 2, and then we have 3 minus 2. Later negative, that's giving us positive. Now the numerator here will give us, that is negative 8. And then negative 2 plus 4, plus 6, that is 4. Minus 3 plus 2, 5. And then 3 minus 2, that is 1. Now negative 8 over 4, this is giving us negative 2 minus 5. And this is just negative 7. Now let's consider this past question. We have ax squared plus bx plus c all over mx plus c. Given that a is 2, x is negative 3, b is negative 2, c is 4, and then m is negative 1. So we have ax squared plus bx plus c all over mx plus c. Now what is our a? Our a is 2. What is our a? Is negative 3. B, that's negative 2. X is negative 3 plus c. What is our c? 4 all over mx. What is our m? Negative 1. What is our x? Negative 3 plus c. What is our c? Our c is giving us 4. Now with this, we know bracket first. So negative 3 squared, that is 9. So we have 2 times 9 plus negative times negative positive. 2 times 3, we have 6 plus 4 all over 3 plus 4. Negative 1 times negative 3. 2 times 9 is giving us 18 plus 6 plus 4 all over 3 plus 4. This is giving us 7. Now 18 plus 6, that's 24. 24 plus 4, that's 28. 28 all over 7. 7 will go into 28, that is 4 times. Let's see the first one. It says that if x is negative 1, y is negative 3, z is negative 4, and w is negative 7, we should evaluate x to the power 3 minus y to the power 2 all over 2w minus z. Now let's substitute. X is negative 1, so you have negative 1 to the power 3 minus y. Y is negative 3 all to the power 2 all over 2 What is W? That is negative 7 minus Z. What is our Z? That's negative 4. Now, the numerator, negative 1 to the power 3, this is negative 1 minus negative 3 all square, that is positive 9. All over, this will give us negative 14 plus 4. 2 times negative 7, that's negative 14. It's a negative, that's positive. And this is giving us the numerator, that is negative 10. Denominator, negative 4 plus negative 14 plus 4. That is negative 10. And when this cancels out, you are going to get 1. Now let's see the second one. Question number 2. We have x all over x minus z equal to y all over z minus y. Now what is x? X is 2. So you have 2 all over 2 minus z equal to y. What is our y? 3 all over, that is z minus 3. We want to find z. What can we do? We can cross multiply. So you have 2z minus 3 equal to 3. 2 minus z. When you expand, you get 2z minus 6 equal to 6 minus 3z. Now let's group like terms. So negative 3z has to move to the left hand side. So we have 2z plus 3z equal to 6 plus 6. This is negative crossing becoming positive. This is negative crossing becoming positive. So we have 5z equal to 12. I want to find z, so I divide both sides by what is multiplying. So I have here, so this is z equal to 12 over 5. Let me leave this in mixed fraction. 5 will go into 10, that is 2 times 2 over 5. Let's consider this July 2005, question number 5a. I are being told to make L the subject of the relation. So A is pi r L plus pi r squared. Now this is the total surface area of a solid cone. We want to make L the subject. So what are you supposed to do? Group like terms. Let the pi r square move to the left hand side. So we have A minus pi r squared, which is equal to pi r L. We want to make L the subject, so we divide both sides by pi r. So A minus pi r squared all over pi r equal to pi r L all over pi r. Because pi r will cancel out pi r. So we have our L to equal to A minus pi r squared all over pi r. The first one says we should make L the subject. Now, what is the second one saying? It is saying that r is 3, A is 176, the pi is 22 over 7. Then we are being told to find, L. So you have to do substitution L. What is our A? 176 minus pi, that's 22 over 7. And then r squared, our r is 3, so you can say 3 squared. Now this is the numerator divided by the denominator, pi r, that is 22 over 7 times 3. So this is the numerator, and then this is the denominator. Now computing this using the calculator, we get that is 1034 all over 7 divided by, this will give us 66 all over 7. 22 times 3, that's 66. Now from here, 1034 over 7. Division will change to multiplication, so, and you have to reciprocate the second term all over 66. Now what can we see? This 7 will cancel this 7, and then from here 3, that is 22, will go into 66, that is 3 times 22 will go into this, that is 47 times. So we have our answer to be 47 all over 3. Now how many times of 47? 3 going to 47, that's 15 times. So you have 15 whole number 2 over 3. Now that's NOVDEC 2002, question number 3b. It is saying that if 1 over m plus 1 over n equal to 1 over p, we should express m in terms of n and p. Now, this in the fraction form. What do? We multiply through with the LCM. In this case, what is the LCM? The LCM is the multiplication of the denominators, that is m and p. So we multiply each term by the LCM. What can we see? This m is cancelling that m. This n is cancelling that n. The p here is also cancelling that p. So what do you have? We have np plus mp equal to mn. We want to make m the subject. So let's take this mp to the other side. So clearly, what do you have? We have that is np to be equal to mn minus mp. We want to make m the subject. So what do? We factorize m out. M, that is n minus p. We have np. We want to make m the subject. So what do? We divide by what is multiplying the m, which is n minus p. So you have np all over n minus p equal to m n minus p all over n minus p. Now this is cancelling out that. So what do you have? We have our m to be equal to np all over n minus p. That's the first one. Now the second one is saying that we should calculate m correct to one decimal place when n, so n is 17.24 and then our p is 16.41. What are we supposed to do? We are supposed to substitute for us to get the value of m. So we have m to be equal to np. That is 17.24 times 16.41 all over n minus p. 17.24 minus 16.41. Now when we use the calculator, we are getting 340.85. But then the question is saying to one decimal place. So you have 340, one decimal place, so the 8. It will change to 9 because of the 5. So 340.9. Let's consider this past question. This is NOVDEC 2012, question number 60. You have been given that s equal to m squared into bracket t p minus n all over 2p n. The first one says we should make p the subject of the relation. So we have x to be equal to m squared tp minus n all over 2pn. Now, this s can be considered as over 1. From here, what do? We can cross multiply. So we have 2spn equal to m squared tp minus n. From here, what do? We expand this using the distributive property. So m squared tp minus m squared n. 2spn. We want to make p the subject. What do? We group like terms. So this has to come here. So clearly we have 2spn minus m squared tp equal to negative m squared n. There's p here, there's p, so we can factorize the p out. And what do you have? 2sn minus m squared t equal to negative m squared n. We want to make p the subject. Therefore, p will be equal to negative m squared n. We divide by what is multiplying the p, which is 2sn minus m squared t. We have made p the subject. The second one is telling us that when m is 4, so m is 4, s is 60, n is 1 over 3, t is 3, we should find the value of p. We don't know the value of p, so we have to do substitution here. Therefore, our p, now negative m squared, so negative, we have 4 squared n times 1 over 3, all over 2, s is 60, n, which is 1 over 3 minus m squared, that is 4 squared, times t, that is 3. Now looking at the numerator, 4 squared is 16 times 1 over 3. So that is, we have the numerator to be 16 over 3. Remember, it's negative. Divided, that's the division sign. Denominator. Now, what do you have here? 3 will go into 60, that is 20. 20 times this, we have 40. Now, 4 squared is 16. 16 times 3, that's 48. Now, this is negative 16 over 3 divided by negative 8. 40 minus 40, that's negative 8. We know that this is over 1. Now, this is the same as negative 16 over 3 times negative 1 all over 8. 8 will go into self 1, 8 will go into 16, that is 2 times negative and negative, positive. So in nutshell, we have 2 over 3. Let's NOVDEC 2016, question number 16 says that, given that 1 over x plus 2 over y equal to 1 over z, we should express y in terms of x and z. And then the second one says that if x is negative 5, z is 10, we should find the value of y, leaving the answer as a mixed number. Now, this what we have is a fractional form. What do? We find the LCM, and the LCM is the multiplication of the denominators, which is what? X, y, z. So I have to multiply each term by the LCM. So the first term, we have x, y, z, 1 over x, plus x, y, z, 2 over y, plus x, y, z, 1 over z. Clearly, this x cancelling another x, this y is cancelling another y, this z is cancelling another z. So what do you have? Y, z, plus 2x, z, equal to, we have x, y. From what we want to do, we want to make y the subject. So it is better we take this y z to the right hand side. So we have 2xz equal to xy minus yz. We want to make y the subject, so we factorize y out. So what do you have? X minus z. We have 2xz. We want to make y the subject, so we divide by what is multiplying the y, which is x minus z. Now this is cancelling others. So you have y to be equal to 2xz all over x minus z. Now what is x? The second one, our x is negative 5, z is 10. We want to find y. What do? We substitute over here. Therefore y will be equal to 2. What is the x? Negative 5. What is the z? Z is 10 all over x, that is negative 5, minus z, that is negative 10. Now 2, 5, that's negative 10 times 10, that's negative 100. All over negative 15, because negative 5 minus 10, that's negative 15. Now this negative will cancel out. 5 will go into 100, that is 20. 5 will go into 15, this is giving us, that's 3. So we have 20 all over 3. How many times will 3 go into 20? That will be 6 times. 2 over 3. Now this is June 2017, question number 9a. We have been given T to be equal to WP into bracket M squared minus M minus S bracket all square. We have been told to make, that is, to make M the subject. Now here, what are you supposed to do? You're supposed to, you see the M, we have M here, we also have M here, which is in bracket. So first, let's deal with the bracket first. Board mass, we have T, WP, we have M squared. Now we have to expand M minus X all square. which is m squared minus 2ms plus s squared. That is the expansion for what is in bracket. There's negative here, so we can expand with the negative. So we have WP into bracket m squared minus m squared plus 2ms minus s squared. Negative times positive, that's negative. Negative, negative, that's positive. Negative times positive, that's negative. What can we see? This and this is cancelling out. So we have WP. This and this will cancel out. So we have 2ms minus x squared. We want to make the subjects. We have to expand. So we have WP, that is 2WPMS, this times this, minus this times that. That is WPS squared. We want to make m the subject, so this has to cross to the other side. So you have T plus WPS equal to 2WPMS. We want to make m the subject, so we divide by what is multiplying it. So clearly, we'll get T plus WPS all over, that is 2WPS equal to 2WPMS all over 2WPS. So this two is cancelling this two, W is cancelling W, P is cancelling P, S is cancelling S. So we have our M to be equal to T plus WPS all over 2WPS. Please, we have to be very careful here with the expansion of this. You have to be very, very careful. This is a past question. We want to make u the subject. We have fx equal to w into v minus u all over 2j. We want to make u the subject. Here, what can we do? We can cross multiply. This is the same as fx over 1, so we can cross multiply. So in this case, we can get 2j fx equal to w v minus u. We want to make u the subject, so we can expand this using the distributive property. We want to make u the subject, so this is negative. Let's bring this to the left hand side and let's take this to the right hand side. So clearly we are going to get w u to be equal to wv minus 2j fx. We want to make u the subject, so we divide both sides by what is multiplying the u, which is w. So we have wu over w, wv minus 2j fx all over w. This is cancelling out that. So our u is wv minus 2j fx all over w. Now, what is our f? What is our x? What is our v? What is our w? So we know that. Now the b, we want to find u. Our f, our w is 1000. So we have 1000 times v. V is 10. Minus 2 times j. Our j is 9.8. Our f is 48. Our x is 32. All over w. What is the w? W is 1000. Now, when we compute this, we will get negative 20.1056. Now, the question says that to two significant figures. This is the first significant figure. This is the second significant figure. So this will be minus 20. That's two significant figures. Let's consider this. This is exam 16, July 2001, question number 6a. We are being given that s to be equal to n over 2 into bracket 2a plus n minus 1d. Now we are going to find the value of n. If A is 3, D is 4, and S is 210. So S, that's 210. Our n, that's what we are looking for. 2A, our A is 3 plus n minus 1. What is our D? Our D is 4. 210 n over 2. 2 times 3, this is giving us 6 plus 4n minus 4. 4 times n, 4 and 4 times this. This is what we have. Now 6 minus 4 is giving us 2. We have 2 plus 4n. 210. What can we do here? We can expand using the distributive property. Now this will cancel this. We have 210. 2 go into self 1. 2 go into 4. That is 2 times. So we have 210 n plus 2n square. Now from here, what are we getting? We are getting a quadratic equation. And from here, so we have to put it in the standard form, which is ax squared plus bx plus c equal to 0. So we have 2n squared plus n minus 210 equal to 0. Now this is quadratic equation and we have to factorize. This of case 2. Now the coefficient of the n square is not 1, so you multiply this by the constant, which is negative 420. So two numbers, when you multiply, you get 420. When you add, you get 1. Clearly the factors are 21 and then 20. So negative 20, positive 21. Now we have 2n squared plus 21n minus 20n minus 210 equal to 0. Now you can factorize n out. What do you have? 2n plus 21. With this 2, what is common? Negative 10 is common. Now what do you have? 2n plus 21 equals 0. 2n plus 21, 2n plus 21. We can factorize 2n plus 21 out. So we have 2n plus 21. What do you have here? N minus 10 equal to 0. We have two things multiplying equal to 0. Here we can use the null factor principle, which says that if you have two things multiplying equal to 0, at least one of them is 0. So here we have 2n plus 21 equals 0, or n minus 10 equals 0. Clearly here you have 2n will be equal to negative 21. N is negative 21 all over 2, or n is equal to 10. But then the condition given to us is that the n should be positive. That is, the n should be greater than 0. Therefore, our n is 10 since the n should be greater than 0. Now let's consider this case. That's the case 3. It says that that is the exponential and roots form. Now let's consider an example. We have make the variables shown in bracket the subject of the formula in each case. The one says that v equal to 1 over 3 pi r squared h. So okay, now we want to make r the subject. So what is the LCM? You know that this one can be considered as over 1, so you can do cross multiplication. So you have 3v equal to pi r squared h. We want to make r the subject. So clearly, let's see, we have r squared here, but what is multiplying? Pi h is multiplying. So we divide by it. So we have 3v all over pi h equal to pi r squared h all over pi h. This pi is cancelling out that pi. This h is cancelling out that h. So we have 3v over pi h equal to r squared. Now we have r squared to be equal to 3v over pi h. Here, when you take the square root, we are going to get plus or minus. But then we can say that taking positive, I'm restricting it, positive square roots. Therefore, I have r to be equal to positive 3 v over pi h. Now let's see the second one. The second question, we have r to be equal to h over 2 plus d squared all over 8h. We want to make d the subject. Now, with this, what is the LCM? The LCM is 8h. So you multiply each term by the LCM, which is 8h. So you have 8h times r, 8h times h over 2, 8h times d squared all over 8h. Now let's see, 2 going to 1, 2 going to 8, that is 4 times. 8h will cancel 8h. So you have 8h r equal to 4h squared, because h times h, that is h squared, plus d squared. We want to make d the subject, so what should we do? Let's bring this to this side. So you have 8hr minus 4h squared equal to d squared. Now taking the positive square root of this, my d will be equal to positive square root of 8hr minus 4h squared. Now let's see question number 3. We want to make r the subject. Clearly the LCM is r squared, so we multiply it with the r squared. Clearly this and this is cancelling out. So we have r squared p equal to m plus r squared k. We have r squared here, we also have r squared here. We can group like terms. So you have r squared p minus r squared k equal to m. What can we see? R squared is common, so we can factorize the r squared out. P minus k equal to m. We want to make r squared the subject, so we divide by what is multiplying it. So you have r squared to be equal to m over p minus k. Now from here we can take the positive square root. When you take square root, it's going to be plus or minus, but here I want to take the positive square root. So the square will now go to square root of m all over p minus k. Now let's see the fourth question. We have L to be equal to G, T all over 2 pi all square. We want to make T the subject. So what do? We can divide through by the G. So we have L over G equal to T over 2 pi all square. We want to make T the subject. Clearly, what do you know? We know from index, if you have A over B all to the power n, this is an over b n. So this can be put in the form that is t squared or possibly this square can change to square root. You can take the positive square root. So we have square root of L over J equal to T all over 2 pi. We want to make T the subject. What's the LCM? So 2 pi, 2 pi. So this will give us 2 pi square root of L over J equal to 2 pi times T all over 2 pi. Clearly this is cancelling out that. So what do you have? We have our T to be equal to 2 pi square root of L all over J. In this case, we want to make M the subject. And we have M to the power 3. We want to make M the subject. So it's better for us to take the x to the left-hand side. So you have M minus x equal to y m cubed. We want to make M the subject. So we divide through by what is multiplying the m, which is y. So we have p minus x all over y equal to m cubed. Now, we want to make m the subject. So clearly, this cube will now go and change to become what? Cube root. So you have cube root, we take cube root of both sides. And that will be our m. So therefore m cube root p minus x all over y. Now we want, it says that make the variables shown in brackets the subject of the formula in each case. The first one, we have a to be equal to square root of h squared plus r squared. We want to make h the subject. Now what we want to make is in a radical. So what do? We have to eliminate the radical. So you say that you square both sides. So clearly we have a squared to equal to h squared plus r squared all squared. So this is cancelling out that. So you have a squared to equal to h squared plus r squared. We want to make h the subject. What should you do? Take the r squared to the other side. So you have a squared minus r squared equal to h squared. From here, we want to make h the subject. So here we can take the positive square root of 8. So we have h to equal to the positive square root a squared minus r squared. Now let's see the second question. Question 2 is saying that t is equal to 2 pi square root of L over J. And then the question says we should make L the subject. What can we see here? 2 pi is multiplying this. So we can divide 2 by 2 pi. So we have t all over 2 pi equal to square root L over J. Now we want to make L the subject. What can we do? And then there's L is under a radical. It's in a radical. So what should we do? We have to take the square of both sides. We have to square both sides. So we square both sides. This is cancelling out that. So you have t over 2 pi all square equal to L over J. We want to make L the subject. What's the LCM? J. So J will come here. So you have L to be equal to J. T over 2 pi all square. Now this question 3 says that you should make T the subject. The T is in a radical. So what should we do? We square both sides. So r squared equal to t minus 3, 9 minus t all squared. Now this will cancel that. So you have r squared to be equal to t minus 3 all over 9 minus t. We want to make t the subject. So what should we do? We can cross multiply. This whole thing is over 1. So we can cross multiply. So you have r squared 9 minus t equal to t minus 3. So here we have r squared 9 minus r squared t equal to t minus 3. I want to make t the subject. There's t here, there's also t here. So let me group like them. So I have r squared 9 plus 3 plus 3. Or here, it will be, when you multiply, that is 9r squared plus 3 equal to t plus r squared t. Now when you multiply, we bring the numerals first before the variables. We want to make t the subject. What can we see over here? We can factorize t. So you have 1 plus r squared. We have 9r squared plus 3. We want to make t the subject. So we divide through by what is multiplying the t, which is 1 plus r squared. So clearly, we have 9r squared plus 3 all over 1 plus r squared equal to t 1 plus r squared all over 1 plus r squared. Now this is cancelling out that. So we have our t to be equal to 9r squared plus 3 all over 1 plus r squared. In this case, we want to make Q the subject. You can see that the Q is in a radical, and then you have 3 over 5 multiplying the radical. Note, we know that if you have AB all to the power n, this is AN BN. Therefore, with this, because it's in the square root, you have to square both sides. Square both sides. So we have p squared equal to 3 over 5 square root of q over r all squared. And this is the same as p squared equal to 3 over 5 square root q over r all squared, because we know AB all to the power n, AN, BN. Now we have p squared equal to, this will give us, that is 9 over 25, that is 3 squared, that's 9, 5 squared, 25, times we have q all over r. We want to make q the subject. Now this is the same as 9q all over 25r. This p squared is over 1, so we can do cross multiplication. And when we do that, we are getting 25 p squared r equal to 9q. We want to make q the subject, so you divide through by 9. So we have 25 p squared r over 9 equal to q. We have been able to make q the subject. Now we have c equal to a plus square root of b minus y over d. We should make y the subject. Now this y is in the radical. So what are we supposed to do first? First, we have to let this a move to the left hand side. So we have c minus a equal to square root of b minus y all over d. Now in this case, we want to make y the subject, but the y is in the radicals. What are you supposed to do? Square both sides. This one you have c minus a square equal to square root of b minus y over d all squared. This will cancel this. C minus a all square equal to b minus y all over d. We want to make y the subject. So multiply this by d, we also multiply that by d. So we have d c minus a square equal to d times b minus y all over d. This is cancelling out that. So what do you have? We have d c minus a square equal to b minus y. We want to make y the subject. This y should move here, this should move there. So you have y to equal to b minus d c minus a square. Question number 6. We are being told to make q the subject. Now this q is in the radical. What do? We have to square both sides. So we have t squared equal to square root of, we have p q over r squared q. You have to square both sides. Now this is cancelling that. So you have t squared equal to p q over r minus r squared q. We want to make q the subject. What's the LCM? LCM is r. So multiply each term by r. So you have r t squared, r times p q over r times r squared q. This is cancelling out this. We have r t squared equal to p q minus r to the power 3 q. We know that in this, when the bases are the same, you are multiplying, we add the exponent. So we want to make q the subject. What did we factorize the q out? What do you have? P minus r to the power 3 rt squared. We want to make q the subject. So we divide through by what is multiplying the q, which is p minus r to the power 3. So you have rt squared all over p minus r to the power 3 q p minus r to the power 3 p minus r to the power 3. This is cancelling of that. So in a nutshell, we have Q to be equal to RT square all over P minus R to the power 3. Example 90, make the variable shown in bracket the subject of the formula in each case. Now the first one, we want to make R the subject. We have V equal to cube root of P plus R. So that's the first one. Now this one is the same, it can be written as P plus R all to the power 1 over 3. Now what should be done so that this cube root goes away? Because it's 1 over 3, so we say we cube both sides. So we say cube both sides. So you have V to the power 3 equal to P plus R 1 over 3 all to the power 3. So this will cancel this. So you have V to the power 3 equal to P plus R. We want to make R the subject, so P has to move to the left-hand side. So you have our R to be equal to V to the power 3 minus P. Now let's see the second one. We have cube root, we have D P plus K square all over Q minus P. This is cube root. We want to make P the subject. What do we do? This cube root, so we cube both sides. So you have D to the power 3 equal to P plus K square all over Q minus P. We cube both sides. So you have D to the power 3. Now this will cancel that. So you have P plus K square all over Q minus P. We want to make P the subject, so we cross multiply. We can expand from here. Now I want to make P the subject. There's P there. So let's take this to the right hand side. So you have D cube Q minus K square equal to P plus D cube P. We can factorize P out. So when factor P out, you have 1 plus D cube. You have D cube Q minus K square. We want to make P the subject. We want to make P the subject. So what do? We divide through by what is multiplying the P. So we have D cube Q minus K square all over 1 plus D to the power 3 equal to P 1 plus D to the power 3 all over 1 plus D to the power 3. This is cancelling out that. We have P to be equal to D to the power 3 Q minus K square all over 1 plus D to the power 3. Example 20, this is question 1. This is SSC 1998, question number 4. It is saying that T equal to square root of P minus R over P plus R. We should find R in terms of P and T. It means that we have to make R the subject. Now what do? We square both sides. So we have T square equal to P minus R, P plus R, all square. So this will cancel out that. So you have T squared to be equal to P minus R, P plus R. Now this T squared is the same as over 1. We can cross multiply from this side. So you have T squared P plus R equal to P minus R. We can expand here. T squared P plus T squared R equal to P minus R. I want to make R the side. There's R here, there's also R here. We have to group like this. So you have T squared R plus R equal to P minus T squared P. R is common, so we factorize R. How do you have T squared plus 1 equal to p minus t squared p. We want to make r the subject, so we divide both sides by t squared plus 1. So we have r t squared plus 1 all over t squared plus 1 equal to p minus t squared p all over t squared plus 1. So this cancels out that. We have r to be p minus t squared p all over t squared plus 1. Now, we want to, it says that the second one says that, the B says that we should find R when T is 3, P is 10. Therefore, R, what is P? 10 minus 3 squared, that's T squared times 10 all over 3 squared plus 1. Now, what do you have? We have 10. 3 squared is 9. 9 times 10, that is 90. 3 squared is 9 plus 1, that is 10. 10 minus 90, that is negative 80 all over 10. And this is negative 8. Now let's see the second question. Given that s equal to k square root of m squared plus n squared, I says we should make m the subject of the relation. This is a past question. Now let's make the subject. Now, the m is in the radical, so what do? We square both sides. Now, we are squaring both sides because what we want to make the subject is in the square root. Now, k is multiplying the square root of m squared plus n squared. What do you know? We know if you have ab all to the power n, the a is multiplying the b. This is equal to an bn. So this, we have x squared, and this becomes k squared m squared plus n all squared. Because if you have ab all to the power n, it's an bn. Like this square will cancel that. So you have s squared equal to k squared m squared plus n squared. We want to make m the subject. What do? We expand using the distributive property. So you have x squared equal to k squared m squared plus k squared n squared. We want to make m the subject. So we group like terms. So you have x squared minus k squared n squared. This has to move there. K squared m squared. Now from here, what can we do? We want to make m the subject, so we divide both sides by k squared. So you have s squared minus k squared n squared all over k squared equal to k squared m squared all over k squared all over just k squared. Now this is cancelling that, so we have m squared to be equal to s squared minus k squared n squared all over k squared. Now, what is m? M is plus or minus anytime you take square root, unless you specify that you are taking just the positive square root. Now, that's it. And then the second one says that s is 12.2, k is 0.02, n is 1.1. We want to find, correct to the nearest whole number, the positive value of m. In this case, we want to find the positive value of m, so we ignore the negative. So square root of s squared, you have 12.2 squared minus k squared, n squared 1.1 squared all over k squared 0.02 all squared. Now when we punch this on the calculator, I get to 606.8817. Now the question says correct to the nearest whole number. 606.8, so this 8 we change this 6. giving us 607. Now, this is example 21. We want to make R the subject. This is O-level June 1996, question number 3A. So you should make R the subject of A minus B equal to square root of B over R plus B squared. You should simplify the expression. Now, this is what we have. We want to make R the subject. The R is in a radical, so what do we square both sides? This is cancelling out that, so you have A minus B square equal to B over R plus B square. We want to make R the subject. Now, what can we do over here? What's the LCM? The LCM is R. Multiply each term by the R. So you have R, A minus B square, R times B over R plus R times B square. So you have R, A minus B square. We have B, because this and this will cancel, plus R, B square. There's R here, there's R there. Now, what can we do? We have to expand what is in brackets here. So you have R. Now, this is A square minus 2AB plus B square. You have B plus R, B square. Now, what can we see? There's R here, there's R there. So let's group like terms. So we have R, A square minus 2AB plus B square minus RB square equal to B. Now R is common here, R is common here. So you can factorize R out. So you have R. And what do you have? That is A square minus 2AB plus B square minus B square equal to B. What can we see? This and that will cancel, so we have R. A square minus 2AB equal to B. I want to make R the subject, so we divide through by what is multiplying the R, which is A square minus 2AB. So my R to be B all over A square minus 2AB. Please note, this B cannot cancel out the B over there. Now let's see the second question. We have Q over M equal to cube root R over A minus A all over T squared. We want to make T the subject. The T is in a radical. So what should we do? This is cube root. So it's better for us to do what? Cube both sides. So you have Q over M all to the power 3 equal to cube root R over A minus A over T squared. We cube both sides. So this will cancel out that. So this will give us Q to the power 3 all over M to the power 3 equal to R over A minus A over T squared. If you have A over B all to the power n, it is AN over BN. Now, we want to make T the subject. What is the LCM? The LCM is AM cubed T. That's the LCM. So we multiply through with the LCM. We have AM cubed T squared multiplied by the first term. R over A minus A m cubed T squared multiplied by A all over T squared. What can we see? This M cube will cancel that M cube. This A will cancel that A. This T squared will cancel that T squared. What do you have? A T squared Q to the power 3. What do you have? M cubed T squared R minus A times A, that is A to the power 2. We have M to the power 3. I want to make t the subject. There's t here, there's t here. Let me take this to this side, then bring this to that side. Negative crossing positive. Equal to m cubed t square r minus a t square q to the power 3. Now we have t square here, t square. We can factorize the t square out. What do you have? M cubed r minus a cube k cube. I have a square m to the power 3. I want to make t the subject, so I divide through by what is multiplying it. So I have a square m cube all over what is multiplying it. That is m cube r minus a k q cube equal to t square. We will divide it through by this. So we want to make t the subject, the square will now change to become square root a square m cube all over m cube r minus a q cube. We have been able to make t the subject. So we can either bring plus or minus, or you see that taking positive square root of it. Now this is 22, May 2018, question number 1b, that is for question 1. Now, in the relation t equal to m square root of n squared plus 4r, the first one says you make n the subject. Now let's see, the n is in the square root, it's in the radical. So what do? We have to square both sides. So what do you have? T squared equal to m square root of n squared plus 4r all squared. Now we know if you have ab all to the power n, this is an bn. Clearly we have t squared to be equal to m squared square root of n squared plus 4r all squared. This is cancelling out that we have t squared to be equal to m squared n squared plus 4r. Now from here, we want to make n the subject. So what do? We have to expand using the distributive property. That is 4m squared r. We want to make n the subject, so this has to move to that side, grouping like terms. We want to make n the subject, so we divide through by m squared. So you have t squared minus 4m squared r all over m squared equal to n squared. Now you have to take square roots, so you have n to be equal to plus or minus square root t squared minus 4m squared r all over m squared. Now the second one is saying that we should find a positive value. So I should find a positive value of n. And we don't know n, but then we know t. T is giving us 25, m is giving us 5, r is 4. Substituting, we get our n to be equal to positive square root t squared, so we have 25 squared, minus 4 times m, so that is 5 squared, times r. What is r? R is 4. All over m squared, that is 5 squared. Now, when you punch the numerator on the calculator, we are getting 225. What is 5 squared? We are getting 25. Now, 25 will go into 225, that is 9 times. And square root of 9, this is 3. Now let's see the second question. We want to make h the subject of the formula 1 over n equal to square root of k squared plus a squared all over h j. We want to make h the subject. Now this h is in a radical, so what should we do? We have to square both sides to eliminate the square root. So you say square both sides. You have to square both sides. So this will cancel that. Now, if you have a over b, now this you have a over b all to the power n. This is a n, b n. In the same way, this becomes 1 square over n square. But 1 square is the same as 1, so you have 1 all over n square equal to k square plus a square all over h j. We want to make j h the subject. What do? We can cross multiply. So you have h j equal to n square k square plus a square. Clearly our h is equal to n square k square plus a square all over j. And this is equal to n square k square n square a square all over j. Now the second part is saying that if n is 8 over 5, a is 3, h is 2, j is 32, we should find the value of k. Now what is h? The h was h square k square plus n square a square all over j. Our h is 2. This is n square, that's n square. Our h is 2. N is 8 over 5 square times k square plus n square, 8 over 5 all square times a square, that is 3 square, all over j. The j is 32. Now this is a whole number, so over 1. What can we do? Cross multiplication. So when you cross multiply, this will come and multiply this, and this will multiply that. So you have 64 equal to, now you have 8 over 5 square k square plus 8 over 5 all square times 3 square. We have 64, 8 square, 64, all over 5 square, that is 25 k square. The same thing over here, 64 all over 25 times 9. Clearly, we have 64 equal to 64 all over 25 k squared. And when we compute, we are getting, that is 576 all over 25. Now, what is the LCM from here? What's the LCM? LCM is 25. We have to multiply each time by the LCM. So, clearly, we have 25 times 64 equal to 25 times 64 over 25 k squared plus 25 times 576 all over 25. Now this is cancelling that, this is cancelling that. So from here we have 25 times 64 equal to k squared, that is 64 k squared plus 576. We want to find k, so this has to move to this side. So we have 25 times 64 minus 576 equals 64 k squared. Now when you compute this on the calculator, we are getting, that is 1024 equal to 647 k squared. We want to find k. So we divide through by what is multiplying it, which is 64. This is cancelling that. So we have k squared. Now 1024 over 64. When you divide, what are we getting? We are getting 16. We want to find k. So clearly k equal to square root of 16. And this is 4. Now, this NOVDEC question 1 is NOVDEC 2017, question number 8a. It says that we should make Q the subject of the relation. Now, there's a relation, and then we are being told to make Q the subject. Now, with this, the Q, this is 1 over 2 to the power 1 over 2, which is square root. So what are we supposed to do? First, group like terms and then square both sides. So from here, you can see that r minus f minus 2, we are grouping like terms, so that we have only the term that will be able to make the subject. Now, from here, what do? We square both sides. Y square both. Why are we squaring both sides? Because this, what we want to look for is in the radical, which is square root. Therefore, we have to square both sides. So you have r minus f over 2 all square equal to f square of 4 plus k square all over half. But we are squaring both sides. Now from indices, we know that if you have a, m, all to the power n, this is a, m, n. You multiply the exponent. Clearly, this will come and multiply this, and the 2 cancel the half. So you have r minus f over 2 square equal to f square over 4 plus k square, and this will cancel this. So this is what we have. Now what do we want to make the subject? Q. So f square over 4 has to come to the left hand side. So you have r minus f over 2 all square minus f square over 4 equal to k square. Now we want to find k, so the square, we take the square root. So you have k to be equal to square root of, that is r minus f over 2 square minus f square all over 4 plus or minus. That is the first one. Now what is the second one saying? It says that you should find correct to the nearest whole number, the positive value. Now with that, we're given f to be 4. That's the second one. F is 4, R is 5. We want to find Q. We don't know Q, but it says that the positive. So Q, only the positive part. R minus F over 2 F square over 4. Now we have to substitute. What is our R? 5. So you have 5 minus F 4, so you have 4 over 2 all square minus f square, so you have 4 square over 4. Now this is equal to square root. We have 5 minus 2 square. 4 over 2 is 2 minus 4, because 4 square we have 16. 16 over 4, that's 4. And this will give us square root of, now 5 minus 2 we have 3. So 3 square minus 4. 3 square is 9. 9 minus 4. So we have square root of 5. Now using the calculator, this will give us 2.236. But then the question says to 3 significant figures. This is the first significant, second, and then 3 significant. So first, second, and this is the third. So this will be, that is 2.24. Because this 6, the 3, 6 will change it to 4. Now question number 2 is NOVDEC 2014, question number 12b. Given the relation t equal to square root of, that is u over 1 over f plus 1 over j, it says that we should make j the subject of the relation. And then the second one, find j when t is 3, f is 4, and then u is 5. So this is what we have. Now I want to make j the subject. Now the j is in a radical. What do? We square both sides. And this implies we have t squared equal to square root of u all over 1 over f, 1 over j. We have to square both sides. So this will cancel that. So what do you have? T squared equal to u all over 1 over f plus 1 over j. Now what can we see here? This is over 1. T squared over 1 is the same as t squared. From here, what can we do? We can cross multiply. So we have t squared 1 over f plus 1 over j equal to u. We can find the LCM here. We have f j as the LCM, and this will give us f will cancel f, we have j, plus j will cancel j, we have f equal to u. Clearly we can expand using the distributive property on the left hand side. So we have t squared j plus t squared f all over fj equal to u. We want to make j the subject. Now there's j here, there's j and those over there. So what can we do? We have to cross multiply. You know that u is the same as u over 1. So here we can cross multiply and say that we have t squared j plus t squared f equal to u f j. This will go and multiply that place. Now clearly we have to group like terms. We have t squared j, we have j here, we have to group the like terms. So we have t squared f equal to u f j minus t squared j. We want to make j the subject. There's j here, there's j there. We have to factorize j out. And what do you have? U f minus t squared, and then we have t squared f. We want to make j the subject, so we divide through by what is multiplying the j. So we have j u f minus t squared all over u f minus t squared. You have t squared f all over u f minus t squared. Now this is cancelling out that. We have j to be equal to t squared f all over u f minus t squared. Now let's see the second part. It says that we should find j when t is 3, f is 4, and then the u is 5. So you have to substitute. Now, what is our j? Our j is that is t squared f all over u f minus t squared. Now, when we substitute, our t is 3, so you have 3 squared times f is 4, all over u 5 times f is 4, minus t squared, that is 3 squared. Now 3 squared is 9, 9 times 4 we have 36, 5 times 4 we have 20, and then 3 squared is 9. Now we have 36, what is 20 minus 9? This is giving us 11. Now how many times will 11 go into 36? That is 3 times. So you have 3 over 3 all over 11. Now we've looked at all the other forms, and now we are on the very last thing, which is the case 4. And with that one, you'll be given a whole lot of variables, and then a variable, or probably 2 or 3 variables, will be told that you would be told that that variable shouldn't be part of it, but then it is not going to be explicitly. Now let's see an example. It says that if v is equal to u plus at and s equal to t over to u plus v. The question is saying that express s in terms of u, a, and t. Look at it. We're given v, u, a, t, and then s. But in this case, they are saying that we should rather express s in terms of what u, a, and t. It means the v is not part, which means that we have to eliminate the v. So how do we do such a thing? Now looking at it, we have v equal to u plus at. Let's call this equation 1. Let's see the second one to s equal to t over 2 u plus v. Equation 2. What can we do? We can put 1 into 2. By so doing, we have eliminated the v. So you say that put 1 into 2. This implies our s is equal to t over 2 u. What is our v? U plus a t. Now from here, what is u plus u? This is giving us 2u. So we have our S to be equal to T over 2 2U plus AT. Now from here, what can we do? We can multiply through with the T over 2. So we have X to be equal to T over 2 times 2U plus T over 2 times AT. What can we see? Clearly, this is cancelling out that. And then, so here we have our S to be equal to UT plus T times T will be T squared, so we say half AT squared. And here we've expressed it only in terms of what? S, U, A, and T. This is May, June 2019, question number 6b. It is saying that given that A equal to BC and N equal to MK over EC, first one is we should express K in terms of A, B, E, M, and N. Now, clearly, we can see that the C is not part, so we have to eliminate the C. Now, the first one, we have A equal to B, C. Here, let's make C the subject. We have A over B equal to BC over B. Clearly, C is equal to A over B. So let's call this one equation 1. Now, let's see the other one. N equal to MK all over EC. We want to eliminate the C, so let's make the C the subject. This is over 1, so we can cross multiply. So we have E and C equal to MK. Clearly, our C is MK all over EN. This is equation 2. We've made C the subject. So what can we see from your 1 is equal to what? 2. Now, what is the 1? If we do 1 equal to 2, then we eliminate the C. We have A over B equal to MK all over EN. From here, what can we do? We can cross multiply. So this implies AEN equal to MBK. We want to make K the subject, so we divide through by what is multiplying the K, which is MB. Therefore, the K is equal to AEN all over BKM. We've been able to know all over MB, all over MB, all over MB. So we've been able to make K the subject. Now, what is the second part saying? It says that we should find correct to three signal figures. When A, we should find K when A is half, B is -4, E is 3, and M is 7. M is 7, N is -5. So let's substitute. So we have our K. Now A, our A is half, our E is 3, our N is -5. All over M, 7, B, -4. What do we have here? 3 times -5, that's -15. So here we have -15 over 2 divided by -28. Why? 7 times 4, that's 28. So the negative. Now this is also over 1. So you have -15 over 2 times 1 over -28. Clear this and this will go away. So you have 15 all over 56. That is 2 times 28. Now 15 over 26, when we compute it on, when we put it on the calculator, what do you have? This is giving us 0.267857. But then the question says to 3 significant figures. This is the first significant, second, and third. So you have 0.268. Now this July 2009, question number 10a, says that if into bracket x plus y all over n minus 1 all square equal to p, and 2s equal to n into bracket y plus x, we should express s in terms of n and p. We had x, y, n, and p, but in this case, there's no x and y. It means we have to eliminate the x and y. Now, what do you have here? we have x plus y all over n minus 1 all square equal to p. Now, clearly, we have to make x plus y the subject. You can see this x plus y is the same as y plus x. We know addition is commutative. So let's make the x plus y the subject. Now let's take the positive square root. So let's taking the positive square root. Now this implies we have x plus y all over n minus 1 equal to square root of p. That is taking the positive square root. If not, it will have been what, plus or minus. But I want to ignore the plus or minus. Now I want to make x plus y the subject, so this will go and multiply that. So I have my x plus y equal to square root of p and minus 1. Let me call this equation 1. Let's also see the other one. 2s equal to ny plus x. Now let's see in this case, can you see here y plus x? This y plus x is the same as what? X plus y is the same thing. So this can be written as 2s equal to n x plus y. It's the same thing. Now the question says we should express s. So here, clearly what can we see here? We can say, let's call this equation 2. So you can say put 1 into 2. So you have 2s, so x plus y, so I have n root p n minus x plus y, which is root p n minus 1. That's what I have over here. And this is the same as 2s. I can multiply the n through, so I can have root p n squared minus n, or I can leave it this way. I want to find x, so clearly my s is equal to root p n squared minus n all over 2. Example 26. This is July 2002, question number 7b. It is saying that if 1 over u plus 1 over v equal to 1 over f and d equal to u plus v. The first one says you should express d in terms of f and u. Now we're having 4 variables, that is u, v, f, and d. But now they are saying that we should only express d in terms of f and u. It means that make the d the subject. Now, it means that they don't want to see v in the final answer. So we should eliminate the v. How can we eliminate the v? Let's make v the subject in the first one. So the first equation, we have this. Clearly, this is a fractional one, so we have to multiply through with the LCM. What is the LCM? U, v, f. So we have u, v, f times the first one, 1 over u, plus u, v, f times the first one, second one over v. U, v, f times 1 over f. Now this u is cancelling out that u, this v is cancelling out that v, this f is cancelling out that f. So what do you have? V, f plus u, f equal to, that is u, v. We want to make v the subject. There's v here, there's v there. So let's take this v to the other side. So we have u, f equal to u, v minus v, f. We want to make v the subject, so we factorize v out. So we have v, u minus f. We have u, f. We want to make v the subject, so we divide through by what is multiplying the v, which is u minus f. Clearly, this is cancelling out that, so we have v to be equal to uf all over u minus f. Let's call this equation 1. And please note, this f cannot cancel that f, this u cannot cancel the u. Why? The denominator, there's no factor of the u and then the f. Now let's see the second one. We have d is equal to u plus v. Now this is equation 2. We are going to make d the subject. So clearly, we can substitute 1 into 2 so that we'll eliminate the v. So you can say put or substitute 1 into 2. This implies our D will be equal to U. Then that is UF all over U minus F. Now from here we can find the LCM, and clearly what is our LCM? Our LCM is U minus F. Now this is over 1. 1 will go into U minus F. How many times? U minus F times. So we have U multiplied by U minus F, plus this will cancel this, plus UF. That is our D. So clearly we have our D. Expanding, we are going to get U squared minus UF plus UF all over U minus F. Now, what can we see clearly? We have negative UF, positive UF. It will cancel out. This and this will go away. So we have U squared all over U minus F. That is our D, the first one. Now, the second one is saying that we should find the value of D. So we should find D when F is 6 and U is 6.5. Clearly, D will be equal to U squared, that is 6.5 squared, all over U. What is the U? U is 6.5 minus F. F is 6. Now, 6.5 squared, using the calculator, that is 42.25. Now 6.5 minus 6, this is 0.5. And when you point this on the calculator, that is 84.5. Now let's see, so if W equal to 2 pi F and L equal to 1 over W squared C, we express F in terms of L and C. Clearly W, the two W's are not mentioned, so we have to eliminate that. So we have W to be equal to 2 pi F. Let's call this equation 1. Then we have L to be equal to 1 over W squared C. Now let's make this one linear. Let's cross multiply this over 1. So you can say L WC W squared C equal to 1. Let's call this 2. So you can say that put 1 into 2. We have L. But then what is our W? 2 pi F squared C equal to 1. Now this is the same as, now let's divide through by LC. So you have 2 pi F all square equal to 1 all over LC. Now with this, what are we getting? We are going to get, that is 2 square pi square F square equal to 1 all over LC. This will give us, that is 4 pi F square 1 all over LC. I want to make F the subject, so I'll divide by what? 4 pi. So I have F square equal to 1 all over 4 pi square. We have LC. Now square will go and change to become, so let's take the positive square root. So we have square root of 1 all over 4 pi square LC. And this is the same as 1 all over square root of 4 pi square LC. Now, if you have A over B all to the power n, this is A n, B n. So that's what we use to compute that. So with this, we have 1 over 2 pi square root of LC. Now with this one, if you have AB all to the power n, we say AN, BN. And if you have square root of AB, say square root of A, square root of B. So that is what we applied here. Now let's see the last question, question 2. If x equal to x plus y minus 2 all over x minus y plus 1 and bx minus 1 equal to 5 into bracket 2x plus 3. We're being told to express y in terms of b. Here we have x, y, and b. But here in this case, we are being told to only express in terms of y and b. It means that we have to eliminate x from the two equations. So from the first one, we have x to be equal to, we have x plus y minus 2 all over x minus y plus 1. This over 1, so we can cross multiply. We have x minus y plus 1 go to x plus y minus 2. Expanding, x squared minus xy plus x plus y minus 2. Now clearly there's x here, so this x and x will cancel out. So we have x squared minus xy equal to y minus 2. So the next one, we can make y the subject. That's why here, let's take this to that side. This negative crossing becoming positive. Negative crossing becoming positive. So we have x squared plus 2 equal to y plus xy. We can factorize y out here. So y, 1 plus x. We have x squared plus 2. From here we can make y the subject. So we have x squared plus 2 all over 1 plus x equal to y, 1 plus x all over 1 plus x. This can cancel out that y to be equal to x squared plus 2 all over 1 plus x. What is the second equation also saying? So let's call this equation 1. The second one also says bx minus 1 equal to 5 2x plus 3. Now from here, let's expand and make x the subject. So we have bx minus 1, 5 times 2, 10x. 5 times 3, 15. Now this should go there, and then this should come. Let's group like them. bx minus 10x equal to 1 plus 15. Why 1? Negative crossing becoming positive. Now we have x, we factorize x out, we have b minus 10 equal to, what do you have here? 16. Clearly our x is 16 all over b minus 10. Now the question says that we should express y in terms of b. So this is equation 2. Clearly you can say, let's put 2 in 1. So wherever I see x, I'll put 16 over b minus 10. So y, that is the numerator, x squared plus 2, so 16 all over b minus 10 all squared plus 2. This is the numerator divided by the denominator, which is saying 1 plus x, which is 16 all over b minus 10. Now, the numerator, what do you have here? This will be 16 squared all over b minus 10 all squared plus 2 divided by, now here, let's find the LCM, that is b minus 10. 1, we can see 1 over 1. 1 will go into b minus 10, that's b minus 10 times. We have b minus 10 plus this will cancel this plus 16. Now, over here, the first one, when you find the LCM, you're going to get b minus 10 all squared. But then the 2 is over 1. This 2 is over 1. So, b squared will cancel b squared. So we have 16 squared plus, clearly 1 will go into b minus 10 all squared is the same thing. So plus 2b minus 10 squared. This is the numerator divided by, now looking at this, negative 10 plus 16, that is positive 6. So you have b plus 6 all over b minus 10. Now division will change to multiplication. So we have 16 squared plus 2, b minus 10 squared all over b minus 10 squared time, then this will reciprocate, b minus 10 all over b plus 6. Now this will cancel one of this. So in a nutshell, we have 16 squared plus 2, b minus 10 squared all over, this will cancel one of this, so b minus 10, b plus 6. And this, you can leave it this way. Thanks a lot for watching. Make sure you subscribe so that any new video we upload, you'll be able to get it.